Hi everyone. So this is a short video on heart rate variability and the long-term impact of traumatic injury sustained in combat on heart rate variability. So to define heart rate variability, it is the small natural variation in time between each heartbeat, and it's an indicator of how well your autonomic nervous system is working. So the autonomic nervous system regulates involuntary physiological processes like heart rate, respiration, and digestion. And it consists of two main control systems, the sympathetic system, which is the fight or flight, and the parasympathetic system, which is known as the rest and digest. And these two systems work together to maintain homeostasis in the body. So heart rate variability measurements can determine if these systems are in balance or if one is more dominant over the other. So a high heart rate variability is correlated to your parasympathetic system, and it is desirable because it reflects the flexibility of your nervous system, meaning it can adapt to stress and easily recover. The parasympathetic system is associated with your vagus nerve, which acts quickly to regulate your heart rate and provide resilience. A lower heart rate variability suggests that your body is under stress and has not fully recovered from a stressful activity or event, and that your fight or flight system is dominant. So, why is variability and flexibility a good thing? I like to use car engine analogies because our bodies are lean, mean fighting machines. But if you think of heart rate variability like a car's transmission, a good engine can shift gears easily and smoothly depending on driving conditions. So if you need to slam on the brakes to avoid hitting the car in front of you, but your car is stuck in drive, that's going to cause some problems. So having a variable heart rate allows your body to adapt to conditions and avoid potential catastrophes. The paper I chose was part of the Armed Services Trauma and Rehabilitation Outcome Study, also known as the ADVANCE study, and which was developed to understand the lifelong effects of combat injury. This is a longitudinal cohort study monitoring the health of United Kingdom or UK veterans deployed to Afghanistan from 2002 to 2014. So, as a result of advances in medical care on the battlefield, many more severely injured soldiers survived the war in Afghanistan. So, because so many lived with serious injuries, it became important to follow them over time to see how those injuries affected their long term health. So, this study investigated a wide range of physical and psychosocial outcomes relating to serious combat injury, including traumatic brain injury, osteoarthritis, mental health, blood biomarkers, and cardiovascular risk and disease. The title of my paper is called The Long-Term Impact of Combat-Related Traumatic Injury on Heart Rate Variability, Findings from the Advanced Study. So, traumatic injury sustained in combat has been associated with negative cardiovascular outcome in veterans, such as metabolic syndrome, arterial stiffness, chronic inflammation, and reduced coronary flow reserve. So, historically, studies of heart rate variability in combat settings have mainly examined acute trauma, which is known to cause significant changes in nervous system and reductions in heart rate variability. However, the long-term effects of combat-related traumatic injuries on heart rate variability has never been investigated in combat veterans. So the purpose of this study was to explore, is there an association between traumatic injury and short-term heart rate variability? And the secondary aim was to investigate the effect of injury severity, injury mechanism, and amputation on heart rate variability. For the study methods, the participants were male servicemen who had served in the UK Armed Forces during Operation Herrick in Afghanistan from 2003 to 2014. And they were divided into injured and uninjured groups. The injured group consisted of 469 veterans who had sustained a serious traumatic injury like a blast injury, burns, laceration, fracture, or amputation during their deployment to Afghanistan and required air medical evacuation for the treatment and management of their injuries. The second group consisted of 506 male veterans that were also deployed in Afghanistan during the same time period but were uninjured. And they were matched by age, height, weight, ethnicity, and military rank. The method of heart rate variability collection was that the participants were required to fast and refrain from smoking for at least 8 hours before HRV assessment. The data was collected during the daytime in a quiet and temperature-controlled room with the participants fully rested and in the supine position, and heart rate variability was measured for 15 minutes. The instrument they used was a gold standard Bidium ECG device that recorded raw ECG data, including the R to R interval, which represents the time between two consecutive heartbeats, which determines heart rate and heart rate variability. The actual heart rate variability values were extrapolated using a biomedical analysis software. So the results of this study, or what the study found, was that soldiers who had serious combat injuries had a lower heart rate variability, which means they had less parasympathetic or rest and recover activity and a higher sympathetic or fight or flight activity. And the more severe the injury, the stronger the stress response tended to be. So soldiers with amputations or blast injuries showed the biggest changes, and a possible cause of this is endothelial dysfunction as a result of vascular damage due to the blast injury. Also, blast waves can cause significant traumatic brain injuries, which affects the brainstem and autonomic functions. Another contributing factor was that the injured group had a higher abdominal obesity as measured by abdominal circumference, which has been negatively associated with cardiovascular health. Additionally, sleep and anxiety disorders were not accounted for, which could also affect one's sympathetic nervous system levels. So what this means is that after approximately 11 years after injury, the veterans had nervous systems that were still in fight or flight mode, which is significant because this prolonged imbalance can increase the risk of heart disease and other long-term health problems. So this adds to our understanding of heart rate variability because we knew that combat traumatic injury is linked to lower HRV and increased cardiovascular risk, but we did not know that the effects could extend long term up to 11 years or longer after injury. So this highlights how chronic stress or trauma can shift the nervous system toward prolonged sympathetic dominance. Because of this, monitoring HRV can be used as a measure to improve health because it provides insight into whether the body is recovering well or operating in a stress dominant state. But heart rate variability is only one piece of the overall health picture because it can be influenced by many different factors like sleep quality, psychological stress, illness, or exercise. So for that reason, it should be interpreted alongside other medical markers like blood pressure, lab work, and clinical assessments to provide a more complete understanding of overall health. So that's all for this video. Thank you for watching, and thanks to all soldiers and veterans around the world for their service. Thanks.